In this video, I hope to explore all possible images created by a convex mirror. And we're going to do this with this fancy image right here, which is awesome because it means I don't have to draw it. Win-win for everyone. All right, so situation number one, let's say that I have some sort of an arrow and we're going to make it straight up and down. We're not going to be complicated. We're going to make it beyond the center, right about here. So my question is, well, what does the image look like? Where is it located? Is it upright? Is it inverted? Is it about the same size, smaller, larger? Is it real, inverted? All of these questions are going to be tied together probably in the next lesson, but for now I just want to explore a ray diagram. So if you need to review the video over plane mirrors and their ray diagrams, feel free to do so. Right now we're going to talk about convex mirrors. So in order to draw a ray diagram, you only need 2 points, 2 rays, and we're going to use these laws or these rules. Rule number 1, if an incident ray is parallel to the principal axis, then it will go through the focus. Okay, and I think I introduced this before, but I just want to make it very clear that these are guidelines for drawing ray diagrams. So if an incident ray is parallel, that means if the principal axis is right here, it's going to go on forever, never touch it. It's going to go through the focus or the focal point. Number 2, if an incident ray goes through the focus, then it's going to come out parallel to the principal axis. Probably harder said than done, honestly. So for this example right here, all we need, okay, light is from some source in the room and it is hitting this arrow at every single possible imaginable direction. And we're only going to focus on 2 possible incident angles or incident rays. The first incident ray is just going to be parallel to the principal axis. So we're going to trace it completely horizontal, going right here. Well, according to rule number 1, if it's parallel to the principal axis, then the reflected ray is going to go through the focus. Please be patient with me as I draw this. Right? All right, the second incident ray that we're going to draw is one that goes through the focus. So if it goes through the focus, it's going to be parallel to the principal axis. So if I draw this directly through the focus, it's going to end up being parallel to the principal axis. Right, now, we did each of these rays for the top of this arrow, which means where they intersect is where the top of the arrow is. So the image is going to look like that. Note, just like a plane mirror system, how we trace these images back, it makes no sense to do it with a convex mirror in this case. Why? Because if you did trace them back, they wouldn't intersect. Or sorry, this one's going through the focus, so they still wouldn't intersect. This one's going here, this one's going here. They never intersect, so that doesn't really make sense to do that. But here's the image. Okay. Now let's do a slightly different one. Okay. Instead of having it straight up like this, what if it were straight down? Okay, well, we're still going to take this top point. We're going to make it parallel to the principal axis, or as parallel as I can make it in this video, which is going to go through the focus. And we're also going to make another incident ray that goes through the focus. And it's going to be parallel. Okay, I want you to notice that if I invert the object, the image gets inverted as well. So this was the tip of the arrow. That is the tip of that arrow. So a few things you might notice right off the bat. If it is outside of the realm of the center of curvature, it's going to be between center of curvature and the focus, the image is. And it's also smaller. Just some things to notice about it. So I'm not going to draw the upright and inverted object every single time. You can just assume that if I flip the object, the image is going to be flipped as well. Okay, let's do a different one as I get the hang of this. Okay, let's say we have an object that is between the center of curvature and focus, right here. Okay, well, ray number 1 is going to be parallel to the principal axis. It's going to go through the focus. Ray number 2 is going to go through the focus. And it's going to be parallel to the principal axis. I've been doing a bad job of being technical. Technically, this should have an arrowhead because it's a ray. All right, so they're going to intersect. And it looks like, since that's the arrowhead, it looks like a few things. Number 1, this image looks to be bigger than our object. And number 2, it's outside of the center of curvature. Okay, and obviously if I flip that, then this would get flipped as well. Okay, what if I had an object right at the center? Right at the center. What would happen? Well, first ray, this one's going to go to focus. Okay, now if it goes through the focus, it's just parallel to the principal axis, which means going this way, and we're going back. Oh, I'm sorry, that makes no sense, because we're going here. Yeah, we're going to go through the focus this way. And it gets traced back to here. Okay, so I know I drew it off, but technically it should be right under this object. Okay, so just to clarify, that's your object. The image is going to be right there, only upright, which I can't apparently draw. All right, what if it's directly at the focus? Well, this is an interesting one. On the one hand, you would reflect this incident ray through the focus. So do this. But the one we can't do is one that goes through the focus. This one's parallel to the principal axis, but we can't really do one through the focus. It rests right on top of the focus. So instead, we're actually going to have to use another incident ray. Now notice that I've used the 2 rules that I've guidelined below as incident rays. 2 incident rays are needed to create this image. Okay, I could use an infinite number of incident rays, and technically that's how it's supposed to be. But for simplicity's sake, and because this is only an arrow, we're just using parallel to the principal axis and through the focus because we know what each of those do, and it makes it really easy to draw a ray diagram. But for this case, we're going to have to draw another one. So I'm going to draw one that does this. And this is where we kind of draw that tangent line. Or we try to. Okay, so it's going to reflect and do a little something like that. It's supposed to do that. I know I didn't draw it to scale necessarily, but it's supposed to be parallel to this ray, meaning that these rays are never ever going to touch. So an image never gets formed. If you have an object directly at the focus of a convex mirror, there is no image. Because these light rays that come off, I can do this for any image that I pick. Okay, any image that I pick. Okay, they're still going to kind of be parallel and never touch. So that's pretty cool. All right, finally, the grand finale. What if it is past the focus? Okay, so here's my object. Pretend that's straight. Okay, and this object is going to get reflected All right, so first I'm going to draw this through the principal axis, and it has to go through the focus. Well, I don't have a focus directly in front, so we're going to have to draw it so that it's behind. Okay. And then finally, one that kind of goes through the focus. Well, because the light rays are striking over here in this direction, that's not really the most plausible idea, but let's say that were to happen. Okay. The light ray is still going to strike it kind of at this direction. It's going to do this. Well, then it's going to go parallel to the principal axis just like before. What do you notice? Well, you should notice that these are never going to touch, but they're not parallel and an image is still formed. But here's the kicker. Remember way back in the beginning when I said that it's pointless to trace these back? I said it for that example because when you traced those back, they never touched. But what happens when you trace these back? So I'm going to trace this one back. Oh, they seem to intersect at a point that is actually higher than the original object. So two things you can notice about this. Number one, it's a virtual image. The other ones were real images because light actually went through them. Light's not going beyond the mirror. It can't go beyond the mirror. That makes no sense. For the same reason that when it was at the focus, we couldn't draw a line through the focus because it can't go, light can't go through an object. And the other thing to notice is this is the tip of the arrowhead. That's the tip of the arrowhead. The image is not inverted, and it's actually larger than the original object. All right, so that is how we explore all the different ray diagrams for an arrowhead. And in the next episode, I hope to kind of tie all this together with location, orientation, size, and type, and explore some other principles of convex mirrors, hopefully tying all of that together.